good morning. Here to talk about how do you work with new technologies as they come down the road, and particularly looking at that from a design perspective. And so I think it helps when you're sort of thinking about and talking about how do you approach a new technology to sort of step back a little bit and look at how a lot of new technology feels to us as consumers, as customers. So let's go back about a year when some of you may recall the Juicero. So the Juicero, an internet-connected fruit and vegetable juicer, came out around $700 or $800. It eventually found its price around $400. But the big innovation of the Juicero fruit and vegetable juicer is that it did not actually juice fruit or vegetables. It only juiced these pre-processed packets. Except it turned out that you actually also didn't even really need the Juicero to squeeze the juice, that you could actually just do it with your hands with the exact same result. So either way, you're just drinking the stuff out of the packet, right? Now you might say, okay, that seems like maybe a little bit much to pay, $700 or $800 for this thing. But hang on, the machine could also helpfully read the barcode that was on the packet, to tell you if the stuff had expired or anything. That information was also printed on the back of the packet, so a little bit dubious. So I think what we wind up here is that you have this expensive kitchen gadget that solves no problems and does no work. And this is actually not a new thing. This is part of the long history, friends, of abuses of designer juicers. This juicer, designed by Philippe Starck, just makes a mess if you try to juice lemons, right? It just winds up with just like lemon juice everywhere, which is okay because it turns out this was not actually designed to juice lemons. It was designed to start conversations, so it's all right there. Friends, this is some bullshit right here. This is the ego of the designer, or often of the technologist. It's the enthusiasm of the making of the thing rather than crafting what service the thing might do, right? So this is sort of a self-serving conceit when I think our job is to serve others. The modern kitchen is full of stuff like this. You've been waiting, I'm sure, for your Wi-Fi-enabled kettle to arrive in your kitchen. There's a Brit named Mark Rittman who owns one of these, and he set about trying to make a cup of tea. But his kettle encountered a little bit of network trouble. It turned out that it couldn't connect, and the kettle asked to be recalibrated. So 3 hours later, the thing had sabotaged his Wi-Fi router, and the kettle had slipped into some unknown nether region, some lost corner of his home network. Mark is undefeated. He's port scanning here, the network, in search of his kettle. And now 10 hours later, he finally got the kettle back online and working. But then, his smart lights cut out because they needed a firmware upgrade. The internet was not terribly impressed, as it turns out. Apologies for the language here, I'm just the messenger. But I think that we understand sort of the sentiment here, and maybe we felt it a little bit before. Here's this Fast Company review of yet another kitchen gadget, and it doesn't even really matter at this point, because I think we recognize this sensation in a lot of the technologies that we adopt that are just sort of coming around, that are promising the new future, right? But you could substitute this review for any number of those kinds of products. This sensation that they're automated yet distracting, boastful yet mediocre, confident yet wrong. You can just sort of hear the people behind it, the funders of it. I work at the intersection of technology and hubris, right? That's sort of like what you can sort of hear those things doing. So these are all sort of signals that we don't yet understand the grain of the technology, how it wants to be used, or how it wants to be of service. And again, it's sort of all this sort of theme of often the ego of the technologist or of the designer. And so when we're approaching a new technology and bringing it into our work, into our digital products, the questions that we sort of want to ask is, how does the technology want to be used in a way that it can be of service, in a way that adds meaning, or even sort of amplifies human potential instead of replacing it? I think these questions are especially important when we turn to new chapters of technology. And I believe that's one of those times that we're working in digital design at a moment that I think is incredibly exciting. It's with the arrival of a new design material in the past couple of years. And I'm thinking about that in terms of machine learning. As Stephen said, I run a design studio across the river in Brooklyn in mighty Kings County called Big Medium. And we specialize in design for what's next, sort of helping companies adopt new technologies in meaningful ways or take on emerging challenges. And I think that, for the last few years, that's really meant thinking about how do we push the frontiers of what mobile is capable of. But I would say that in the last couple of years, that's begun to change as more and more companies are coming to us and being like, how do we work with data? How do we work with machine learning and all kinds of different new and interesting ways? And so in the same way that mobile defined the last decade of digital product design, I believe machine learning is already defining the next. And this is something that is sort of like, it's urgently necessary for designers and the developers of interfaces to become engaged with this, because until now, we largely haven't. So, because machine learning is a design material, just like HTML and CSS are design materials, just like great prose or copy is a design material, or dense data is a design material. And like any design material, it's important to understand its texture, not only how it can be used, but how it wants to be used. And so when you ask, what does it mean to use a new design material, we have to ask ourselves these questions of what can it do? Why should we use it? What is it capable of? But importantly, what is its grain? What is the unusual texture that suggests that we need to treat or use this technology in a new way? And by using it, what does it change in us? What does it require of us in return? So that's what I want to talk about today, sort of these three questions through the lens of machine learning. Does that sound all right? You guys doing okay? You look great. Just want to let you know. Thanks, Aaron. All right. So let's start with the first question. What's it for? Or put another way, why would you team up with machine learning as a designer? What does that mean for you as a product designer and interface designer? Basically, the entire promise of what machine learning is that it's just pattern matching at sort of an unprecedented scale. So what if we could detect patterns in anything and act on them? I mean, that's the nut of it. That's really what this thing offers us. And at this time, machine learning is already driving so many of the digital products that all of us use every day, for better and for worse. Algorithms are determining the news that we see, the movies that are recommended to us, the products that are surfaced, the way we drive home from work. Right? This is all pattern matching, powered by machine learning surfacing generally useful insights. So what does that mean for you and your everyday practice is what I want to explore. And there are basically sort of 5 applications of machine learning that you can bring into products. I'm going to talk about 3 of them in particular, these first 3. So just very quickly, just a sort of a survey of what they are. Recommendation is one kind of use. Slack launched a feature about a year ago for big teams that helps you find people who talk about certain topics. Right? So this is machine learning that helps you find experts in your organization. If you need an expert in hiring process, Isabella is your go-to. Right? So this is more than just sort of brute force keyword pattern matching. It's starting to match people to concepts that they talk about a lot. So this is recommendation, very sort of simple, familiar pattern, right? It's a ranked list of documents that match a specific context or concept. And it's closely related to classification, which I'll talk about in a moment, but also to prediction. So let's talk about that. Predictive keyboards, right? Another example of just everyday machine learning, the statistically most likely next word showing up above the keyboard. So it's a simple intervention to speed this error-prone task of touchscreen typing, right? That's prediction. Based on historical data, here are the things that are most likely to happen next in any given context. Classification is a fun example, I think is especially useful for just sort of everyday interfaces. So Google Forms, which is likely familiar to many of you, is sort of survey builder tool. When you add your questions, you choose the format that you want the answer in. So the default, as you see here, is multiple choice, radio buttons. But there are a lot of options here, and they've tried to make it as simple as they could to sort of understand what those options are, but it still takes some time and thought. But look what happens when you start typing the question text and how that changes the answer format. So how satisfied are you maps to a linear scale. So they added a little machine learning to the mix to look at your question and classify it to a specific answer type. Which of the following apply maps to checkboxes. And just this convenient sort of little bit of intelligence to make the process easier, to change the default before you get to it. So classification is human-generated categories, right? They've sort of said, great, we've got these, whatever it is, 12 or 13 types of answers. And then the machines map content, in this case, these questions, to those categories and sort of helpfully suggest and sort of map those things. So what I'm suggesting here, you can quote me on this, is, friends, sprinkle a little machine learning on it, right? And you might be looking at these and saying, this is not my sentient robot butler. This is not the singularity. I thought artificial intelligence was supposed to be a lot more highfalutin than this. Notice how mundane a lot of these examples are. The point here that I want to make is machine learning can be part of your everyday kit. We need to get comfortable designing for the algorithm, as comfortable as we are designing for the small screen. Or just as it's second nature now to add interaction to a web page using JavaScript, now we can add intelligence to a page with machine learning. And I'll mention some of the services that are available to us with the skills that we already have as sort of, mainstream, everyday designers and developers. It doesn't take special skills to use the services that are available to start to integrate some of these things into our interfaces. So this is an enhancement. It's becoming part of the everyday for sort of a select few companies right now. And I think for everyone very shortly. The tools are already here and accessible for everyone. So my message to you is get cozy with casual uses of machine learning, that we can bring a little bit of humility to our fancy new technology. It doesn't have to be a big deal. In many cases right now, I think machine learning is actually best deployed in these sort of small interventions that solve critical tasks in any given activity. But there are bigger opportunities too. So I want to see what happens when we aim the machine learning at the kind of work that we all do here in this room. You might recall a couple of years ago, Quick Draw. It was a Google experiment to identify sketches. It's sort of like Pictionary in a web page, only it's a machine that's guessing. So the way that it worked is that you would prompt you to draw something, a mountain, right? Great, it's like, great, I know it's a mountain, right? Guesses it right away, figured that one out. Okay, draw a calculator. You can see it guessing. I see a square, a triangle, an elbow, a dishwasher. It's a calculator. All right, hamburger. See how we do here? I'm drawing it, and it's saying, I see a shoe. I see a hot dog, a hot tub, bread. It's a hamburger. Nearly got my hot tub rendering. All right, one last one here. Let's see how it does with flip-flops. It's a nose. It's a potato. It's a peanut. It's flip-flops. That is not a flip-flop. It's clearly not a flip-flop, and yet it recognized it there. I drew this sort of like completely awful version of a flip-flop. What I think is interesting is when you can look at sort of how other people did with it, it shows you what your drawing looked like. So it was a flip-flop it identified, but it could have been maybe a potato or bread. It's adjacent. A flip-flop, it turns out, is adjacent to potato. But you can see what other people drew. And then you can see some similarities here, right? That what it's really doing and identifying is symbols for things, not actual images. It's identifying the sort of the common symbolic language that we have around some of these things. That the essential part of a flip-flop, it turns out, is this potato shape with a little kind of chevron in it, right? We draw symbols all the time in our work that don't look like the final result, but that we have all kinds of symbols that we use to represent final interface elements. What if machines could learn what those mean? And of course, there are a whole lot of experiments in this right now. I'll just show you one of them. This is called Wizard, I think. U-I-Z-A-R-D, like GUI-zard, only Wizard. Anyway, you decide. Wizard.io. And it's a web app. You just go and you can open it up, and it prompts you to take a picture of this sketch. It's a very sort of simple kind of inbox sketch that I drew. And then after that, it takes about maybe 15 seconds or so. You can sort of go, and it's just for ease, I'll take you to the desktop view where you can see my sketch on the left and what it generated there on the right. It's still doing okay. You can see it added in an extra search box for some reason. It's a little bit brittle, and it has this limited set of patterns that it understands. And most important, they may not be your patterns, right, or your design style, or your code conventions. But let's take a look at what it actually does give you. It gives you a sketch file. It also gives you HTML. And so when you go in and you look at what that sketch file looks like, you can see that it's not just generating sort of a static image. This is stuff that you can actually go in and edit. So it understands this is the symbol for text, and now that's an editable text file. This is an image that I can drag around. So again, it's mapped those symbols to specific elements in Sketch. And in fact, if we go in, we can see, oh, it's a library. These are all symbols inside Sketch. So it's done this sort of very simple thing of, remember the categorization that we saw with Google Forms? We've now sort of said, oh, great, it recognizes these symbols and is categorizing those to this fixed set of symbols in Sketch. Right? The HTML isn't too bad. It's because it's also sort of not trying to do sort of something of trying to understand what this sketch is and sort of trying to actually build something normal to it. Like, it's basically saying, oh, I recognize these elements, and I will stack them all on top of them with this sort of prefab code. So what is it in fact doing is it's mapping patterns to a familiar vocabulary. So what if you taught the machines the patterns and symbols for the standard vocabulary that we use in design? When we do that for humans, we call that a design system. Those are kind of hot these days, right? So what if we bring the machines into this thing? Design systems establish standard patterns and a common vocabulary for people. And if you've established that, you can share that language with the machines too. Add to it the symbols and notations that you already use. And speaking of vocabulary, once we're doing this, maybe you don't even need the sketch in the first place. Maybe you can say, Alexa, give me the interface, right? In the same way that you could do that between a designer and a developer, just talk through it really quickly because you have this established vocabulary. So it's actually, we're not that far from it with the systems that we're building, where we're giving names to sort of specific patterns and specific code and specific presentation. What if we just let the machines line those up? Some of you may be thinking, well, that sounds a lot like my job. I'm the one who makes those sort of prototypes. And I would say that's actually not your job. That's the clerical part of your job. That's transcription. That's sort of dutifully translating a sketch or a set of vocabulary to a comp and markup. That when we're dealing with sort of the solved problems that a design system gives you of complete patterns, that's not the work, right? That's sort of just assembly. And that's something that the machines are great at. That's not where the real thinking happens. So the whole idea of a design system encoding those solved problems, that's something that the machines can help us to assemble. So if you think about it, these are actually that kind of transcription that's actually sort of like falls into this category of tasks that generally we aren't that great at, right? Which is time-consuming and repetitive, detail-oriented, error-prone, joyless tasks. The stuff that you wake up in the morning, you're like, I can't wait to go to work and do more joyless tasks. It turns out that the machines do wake up thinking about that. They love this stuff. This is what the machines are great at. So let's let the machines do those things so we can focus on what we do best. So here's one example. We did some work with a healthcare company, and they were zeroing in on ways to help radiologists do their jobs better. So these are the folks who examine x-rays looking for problems. And so much of their time, it turns out, is not sort of like figuring out this one problem here, but it's actually just looking at scan after scan after scan, looking for the same telltale signs. Most of those work is actually looking at scans that have no problems, where there's nothing there at all. So only occasionally, and importantly, do they find a mass, right, and engage their actual skill to determine what that mass is, what kind it is, what it means for the patient. So what we were able to do is get camera vision to do a huge amount of triage with obviously, really sort of a very high level of sensitivity. We don't want any false negatives to pass so that we're actually missing something important. But then the radiologist could actually apply their actual expertise. So the machines bring the radiologists interesting cases. They look over the time-consuming, repetitive, detail-oriented, joyless tasks of sort of that triage work. So the radiologists can do what they do best. So that's the idea, I think, and the promise of this as we start to think about how do we bring machine learning and bring the robots into our products, is that the goal is not to replace people, but to focus their attention, to let people do what they do best and let the machines do what they do best, because they are almost never the same thing. So amplify our humanity by supporting our activities in ways that are uniquely possible through this kind of machine learning. So the goal, what we should ask ourselves when we ask what machine learning can do, is how can we focus attention and judgment? That's what the designer's question is here. So the effort is not to replace attention and judgment, but to focus it, right? To clear away the noise and help signal what we can do and how we can help to help people do our most interesting and creative work. Our industry has spent a lot of time to make the machines smarter. I think let's instead put a premium on how we might augment human capability and start with that human need. So basically understanding conceptual relationships between documents or people or trends. So the Slack example is another example, right? This is a question that we often ask, but we can do it in a smarter way. Instead of sort of doing a brute force keyword search for that sort of human resources question that we saw there, we can just sort of ask, who is good at this concept? So it's being smarter about questions we're already asking. I think it gets more interesting when it actually asks you to start asking entirely new kinds of questions. So instead of a keyword search, for example, we can instead ask questions based on emotion. So a customer care center, for example, can look can just sort of search for upset or urgent. Or maybe that's not the way you want to start your day. You want to look for kind and complimentary. So it's this idea that it's actually now being able to find patterns and mapping them to emotions lets us ask new kinds of questions. I think more and more, too, we're seeing the ability now to unlock new sources of data. So as the machines have become smart enough to find patterns in images and in audio, they're able to make sense of all the messy ways that we communicate, right? Through the kinds of sketches that we saw, or through identifying what's happening in a video, or photos, or to understand speech. What all that means is that they are actually, all these things that used to be opaque to the machines can now be interesting sources of data, or even a surface of interaction. So what are the possibilities there? And the last one, I think this is particularly interesting, is surfacing invisible patterns. Being able to sort of find connections that we weren't able to see before. So a lot of times this is basically just what's called clustering, giving the machines a huge mountain of data and letting them sort of start to identify patterns within it and group things together. So what the machines are great at is figuring out what's normal in this set and then finding things that are different in interesting ways. So what this means is it can do things like identify fraud, right? That's how the credit card companies know to get in touch with you about that one specific purchase, or to identify disease in a healthcare thing, or crime. So all these sort of outliers in a sense. But it can also identify new sort of customer segments. These people are sort of buying things in the same way. All these sort of different ways to surface problems. So the point here is that for UX designers and product designers especially, the goal is to figure out how can we point artificial intelligence at problems worth solving through that kind of lens. And that's important because it takes effort and data and process change to get this stuff done. So choosing that right question, that right point of intervention, like we did with the radiologists, is really important. What's that human need and how can machines help to solve it? All right. I want to turn a little bit to sort of like, all right, great. So we've figured out what we're going to do with this stuff. What does it mean to work with machine learning? And what are the unique qualities, the grain of this design material that give us cues about how we should work with it? What are its strengths and weaknesses, in other words? And there are a lot of them, but today I want to talk about 3 of them. And the first sort of characteristic of machine learning that I want to talk about is that, man, the machines are weird, all right? They come up with, they see the world from a different perspective than we do, and often come up with conclusions that are surprising as a result. So, for example, it takes a human being about 14,000 brain hours to learn to run. Now, it turns out that an artificial intelligence can figure out how to run in less than half as many CPU hours, but the results are like this, right? So sort of using the arms for forward momentum, sort of very little consideration of the physics of friction or the realities. You can see of the rotator cuffs, right? But then again, we also come up with pretty strange approaches to locomotion ourselves as human beings. Let me just sort of take us back to 2013, to the prancer-size craze of southern Florida, where it's like, all right, this is its own kind of, maybe not entirely different sort of locomotion when you sort of look at it there, right? So when people are so difficult to understand, so often unpredictable and eccentric, how can we expect the machines always to make sense of what's happening, right? So in other words, if the machines are weird, it's in large part because we're pretty weird too, right? We may never totally understand what we look like to the machines on the other side. We communicate and behave in ways that are not always predictable, or that themselves are somewhat fanciful. And so what do the machines make of us as creators or artists? This Renoir painting is in the collection of the Barnes Foundation in Philadelphia. And when the curators there ran it through a computer vision algorithm for identification, the robots confidently identified it as a boy holding a teddy bear. Right? Now, you might look at this and be like, well, this seems like kind of a bust, right? It's like back to the drawing board. This is obviously something we can't be automatically tagging our collection based on this sort of flawed technology. But it turns out that the curators didn't sort of strictly see this as a failure. For example, when they asked a neural network to find cherubs in their collection, it found things that were definitely not cherubs, but that also were kind of cherub-like. So the curators began to find some interesting connections in their own collection that they hadn't seen before. That as it was sort of starting to find some of those invisible patterns, clustering items itself by its own sort of logic, they got this, as I say, sort of productive friction of the way that they look at or consider their collection. Shelley Bernstein led this machine learning effort, and she described these connections as magic, that these unexpected results had generated new insights. So I think that's one takeaway that I'd really like to encourage you to think about here, is that the machines will come up with unusual suggestions, which you can't necessarily take at face value, but that often will start to stir interesting connections. So consider this a productive friction, that the patterns and connections that they surface can be interesting, that these are things that would otherwise be invisible to us. So, looking at connections between artworks also means, you can use it, and I mentioned some of these other sorts of clusterings before, but find clusters of products and or of customers or of people, this behaviors by or associations that might not be immediately apparent or obvious. So embrace the unexpected. May as well talk about unexpected visitors too. BJ May has one of those fancy Nest doorbells with a connected camera, and he had sort of rigged it up a little bit too to sort of do a little something special so that when it doesn't recognize someone, it locks the door. And one day it locked on him. And so he did a little bit of investigation and looking back at the app's history and saw that the system had in fact identified a new person and was like, do you want to let this guy in? Because I'm thinking no. Seems a little angry, right? So the machines perceive and interpret the world, again, just sort of very differently than we do. So this weirdness and unpredictability and mistakes are really essential to this design material. So the more that I work with machine-generated results and machine-generated content, and especially machine-generated interaction, where the system is running the sort of the response to the human being, the more that I realize I am not in control of that experience as a designer. And that's new. I think that for the history of human-computer interface design, we've been used to designing a fixed path through information and interactions that we control, that we're used to designing the happy path. Now we have to anticipate unknown content with this fuzzy range of results. And so I think actually one of the things is not just anticipating that kind of failure and uncertainty, but how do you actually design for it? And I think one of the things is actually it has to do with a little bit of manner. And the answer, of course, as you're well familiar, is likely it's base app. All right, there's no reason why you would know base app. All right. This is a phrase from Matt Jones of the late great digital agency Berg London, which is a pioneer in kind of connected devices and digital weirdness. Matt's at Google now. And he came up with this way to think about creating honest, gentle interfaces for our weird systems. Be as smart as a puppy is the idea there. So our goal should be making things that don't try to be too smart and that make endearing failures in their attempts to learn and improve. So puppies screw up all the time, right? But they've sort of set our puppy-like expectation for the ways that they're going to delight us sometimes, but also make us crazy, make a mess, right? So one of our goals then is like, how can we make these systems be like puppies? Or, like robot soccer players.
Elusive. Can it contain him? Snapping ankles along the way. Run again! This run is uncontainable!
Goal! All right. So in other words, sort of the expectation is sort of set by just looking at these things, that these are not going to be great soccer players, right? But man, they're trying, they're getting after it. The right manner helps us to kind of anticipate and forgive and recover from errors. So sometimes it can be annoying, those errors, of course. Even puppies can be annoying. But it won't surprise us, or at worst, endanger us. So too often when machines make a mistake, it simply sort of feels like this. It's just a doll, just a doll. Whew. All right, just a doll. All right. That's about the design, right? How do we cushion mistakes? How do we set expectations? Because this is always our job, but I think even more now that we're sort of giving a lot of responsibility to the machines, is how do we set expectations and channel behavior in a way that matches up to the system's ability? So Alexa and Siri and Google Assistant, all of them overpromise. Their promise is, you can ask me anything. And as capable as these systems are, that expectation is one that they can never meet. So they constantly disappoint us because they don't meet the sort of promise and invitation that they make. So we run into these miscalibrated expectations all the time. I'm going to introduce you to PickDeskBot. It's a Twitter bot that basically takes random images from the internet and feeds them to Microsoft's image recognition service, very easy to use web service that anyone can get access to, and then sort of faithfully represents, here's how the system describes it. So here you can see it. This is a pretty complex image, and it actually has this almost sort of lyrical description. It's a herd of cattle grazing on a lush green field, right? It does get confused sometimes, kind of charming and weird when it gets a little bit mixed up. You might be familiar with Samsung's latest model here. They keep getting bigger and bigger. So the problem here is not merely that it's not accurate. That's a data science problem. But it's also the undeserved confidence of the statement, of the presentation of it. And that's a problem of presentation and of design. So research on machine-generated descriptions finds that most people prefer results that are vague to those that are just flat out wrong. So when the algorithm's confidence is low about the answer, and we'll look at that in a moment, it's better to dial down the specificity to improve accuracy. So a person holding an object is actually better, if not exactly super descriptive. But what if we split the difference and offer some of the low confidence possibilities in a way that a human being might, right? So it's a person holding an object that's maybe a cell phone? We're starting to get, both in terms of the language and the manner, sort of something that's being able to express how you should interpret that information. Or maybe it's a guitar or a violin. So this is actually more representative of how the machines see the world, that there are a bunch of competing possibilities, competing signals that the machines receive. And they often sort of give this probability of what it is. But we rarely surface that in our interfaces, and we should. Because the machines are weird, we need to match language and manner to the system ability, that the presentation of machine-generated results is as important as the underlying algorithm. And the thing that enables this flexibility is that algorithms, as I say, sort of faithfully report their confidence in the answer. And that's because, and this is sort of the second aspect of the grain of machine learning, is it's really important to understand that machine learning is probabilistic, that machine learning sees the world in shades of gray. We tend to think of these things as giving answers. It's like, this is it, this is the answer, this is the direction to go in. The systems do not see that way. Nothing is fixed, it's all probabilities. And its algorithms are explicit about their confidence in their predictions. So one way, and I really encourage you all to play with this to find out how actually easy it is to work with machine-generated results, but also to understand kind of what they're good at and what they're bad at. There are a whole bunch of services like Microsoft's cognitive services, Google, Amazon, IBM, they all have this stuff, easy to work with, essentially free to use and play with. You get access to machine learning superpowers around vision and speech and language and more. Amazon, essentially for free, gives you everything you need to build an Alexa-like service. Anyway, just to give it a spin and to give a sense of this, I am just exactly self-absorbed enough to be like, I'm going to take my own picture and give it to them. And let's see what Microsoft's image recognition service comes back with. You get this structured data in return. These are sort of your ingredients as a designer. And you can see it actually does pretty well. It's a man looking at the camera, and it's telling you how confident it is. Pretty confident, 89%. I'm not totally sure about some of the tags that it's coming back with. You know, it's just like oh yeah, come on. That one hurts. That one's I'm working on it. That one sort of stings a little bit. But if you look at the percentages to get a sense of the confidence here, you know, so down here at the bottom, you have these things around the individual tags, and you can see that person and man and indoor are all very high confident, right? So it's like when you can sort of take from that when you compare it to the man looking at the camera, which has a lower confidence. It's like, oh, all right, it's confident that it's a man. It's not quite sure where the man is looking. But we can also see, I'm happy to say, is that older, it's only 28% confident that I'm older. And if you look at this too, this also maps to the order that the tags are. So the tags are given in a sort of a confident description. Elephant, I'm happy to say, is last. So if you were going to do this, you know, what you wouldn't want to sort of say is, this is clearly an older elephant, right? It's sort of like, this is a man who looks like an older elephant. I'm still not very flattered, but I appreciate a little bit some of the nuance, right, in that manner. And I think what you can sort of see just from this very simple example is that the machines do represent a lot of nuance and also show when they're confident and when they're not. And as you sort of use a service, and if you decide that you trust its confidence, that it knows when it's wrong or when it's uncertain, then you can start to surface that nuance in your interface. And now look, as much as I admit that I really do care whether or not I look like an aging elephant, there are a lot more sort of important and sort of pressing things in sort of this realm of image recognition. This has been in the press a lot lately, starting to see the police using face recognition algorithms or pattern matching for predictive policing to sort of pluck suspects out of the wild. And that's pretty serious. You know, the machine's up to it. The ACLU last year ran photos of Congress against a data set of 25,000 mugshots, and they got 28 matches. So Amazon has confirmed with science that Congress is a bunch of crooks. All right. But if we look under the hood here, ACLU left the setting to the default for face recognition at Amazon, which declares a match when there's 80% or better confidence. And Amazon, of course, was not very happy with this sort of like press coverage that they were getting. And they countered and said, whoa, hang on, we tell the police departments to use at least 95% confidence. It's a probabilistic tool. You have to choose an appropriate level of probability to match the seriousness of the problem. But in a way, that makes the ACLU's point. The machines require careful tending. Those of us close to the machines need to understand how confident and accurate they are, of course. But we also need to make it transparent to the users, the civilians, who get those results from us. Because this can have real impact, hurtful impact. And so, as so often is the case just with us as humans, we can sort of help the machines to sort of understand that I don't know is better than a wrong answer. And a lot of times we are rushing to provide an answer. We do that a lot in our personal lives. I don't know is a hard thing to say. And it's hard to train a machine to say it. But it's actually, it's something that we should do. That, you know, maybe an older man could be an elephant? How do you turn that into a suggestion, in other words, instead of flatly saying, this is an older elephant? This is one of the most important takeaways that I'll say with this, as you're starting to work with these things, machine-generated results, is that it's so important to present the information as signals and not as answers. The manner that we present information is astoundingly important. And the way that we think about these signals is important too, because they're always sort of signals relative to the baseline. That's sort of the last thing that I want to talk about here for what the grain of machine learning is. The whole idea is to identify and categorize the typical, the normal, so it can then predict or recommend the next normal thing, or identify things that are outside the norm, things like I mentioned, like fraud or crime or disease. But what is normal? And according to whom? You know, so if you give Microsoft's image recognition service this picture of David Bowie, it sees a 29-year-old woman. So at a moment when our culture is in the thick of a shifting understanding of sexuality and of gender, how are the machines supposed to keep up with that? This idea that normal is a mutable idea, not just in culture, but in data. And that it's an idea that's rarely a perfect one. So a system's output is only as good as its input. So what if the prevailing notion of normal is actually garbage? What if our machines are learning from us our own bad or dubious choices? What if they absorb and reinforce existing inequalities or leave out entire categories of people? Amazon discovered that the system it used to filter and recommend people for jobs was biased against women. The historical data and the characteristics it had optimized for favored men. That wasn't the outcome that they wanted, but it was the outcome they got based on their own sort of decisions of what they wanted to optimize for, and again, that historical data. And that's really bad news. But the less bad news is that when they discovered it, they pulled it. They said, this is not the system that we want to do. This is not what we're trying to optimize for. The machines had helped them recognize a systemic problem, even as it sought to reinforce it. And so if there is a silver lining in this very serious issue, the idea that surfacing bias then allows us to act on it. Because the machines surface this bias naively, right, in a matter-of-fact way, without obfuscating it, without embarrassment. They make obvious what's always lurked beneath. So this reveals the problems that we have to solve or address, maybe in our mathematical models, maybe in the way our culture operates, or the limitations of our own narrow professional circles. So when bias is revealed, we can act on it. It gives us signals for necessary change. We may not be able to eliminate bias from our data, but we can certainly surface that bias as a call to action. And that sort of gets just to this last thing that I just want to close with here, is just this idea that what intentions will we bring to our technologies, and how willing are we to consider that things will go wrong and that the technology will have unintended consequences? Because if we don't choose that, then the technology will roll on and make those decisions for us. Right? And I think that the one thing we can probably agree on is that the future shouldn't be self-driving, right? Otherwise, it's the technology that runs the show, and it's the tea kettle holding Mark Rittman's family hostage, working hard to restore the network just to normalize their life and keep the kettle happy. So let's be explicit about the vision that we want instead, not just how we want the tech to function, but what it might enable. Just a very quick example. What if when you're sick, the machines can handle the diagnosis? And if the experience ended there, that would be abject, right? That would be even worse than our miserable healthcare system now. But what if then the doctor came in, and their job is not to do the analysis, the machines have already done it, but to deliver the message in a way that is caring and warm, right? That doctors will let patients tell their stories. Instead of 5 minutes with the doctor, the patient will get time to feel heard and ask questions and be reassured. And perhaps that caregiver doesn't need to have as much education, which makes for less expensive healthcare, which means we can have more caregivers for more jobs. So it's like these values of compassion and affordable healthcare and employment, those feel like better values than efficiency, which I think is often the starting point. So it's like, what is the outcome of the products that we make? What do we want to see beyond the immediate interface? And how do we design to that? So instead of humans working for the machines can amplify our potential by doing those joyless tasks for us, delivering new insight from it. We don't have to be passive recipients of an algorithmic news feed. There are new design patterns to be invented. Instead of hijacking our agency, the machines can augment our judgments so that we can be more creative, more insightful, more compassionate. And that's up to us, the people in this room. We're the ones designing this. As we've seen, this can go sideways in a million different ways. I choose to be optimistic and excited that this design material is ready for us to use today with the services like some of the ones that we've just seen. Put those tools to work in small interventions or in audacious projects. It's up to you. You have the chance today in your organization now to make something amazing. So please do that. If you're interested in this, I want to point you to 3 resources in particular. Mindful technology is a movement and a sort of set of resources for creating products that focus attention instead of distract it. UVET Agenda is the output of a retreat that I went on with a bunch of researchers and academics and designers and science fiction writers about the future of artificial intelligence. And my own site, Big Medium, where you can find more writings and talks and ideas and techniques about how to work with this stuff, which really leaves only one last thing to say. I don't know. What she's saying is, let's stop talking and get to walking. Thank you very much.